So as you can see, I'm Adam. Hey. Hi. My first talk, so go easy. If any of you are concerned that this is going to be one of those talks where I tell you about how SQL or Data Mapper is better than ACTIVERECORD, that's not what this is about. This is actually going to be more of the sort of snooze fest where we talk about SQL and how wonderful it is. And my goal for the day is to keep at least half of you awake. I work for a company called Blix. We measure foot traffic and engagement of people coming into your location. So we might tell you how many people are coming into your store, how many people walk past it, did any of those people who previously walked past go in, are you missing sales opportunities, this sort of data. And after spending a lot of time nagging senior management, they finally allowed me to do some performance optimizations. And I guess this is a bit of a story of that process, finding where there was trouble and working out how to optimize the queries that were going on. So as I say, to kind of oversimplify the shit out of this, we take sensor data, and that sensor data gets pushed into a Postgres database. From there is some magic that happens, and we have to then apply a scaling ratio. So we know that we are not going to be able to sense every single person that passes. So we have to work out what's the missing number of people. And it's they're producing this scaling ratio that's kind of the focus of what I was looking at here. Kind of break that down a bit. We obviously have a table that would store our visits. And so for a location, we may have had a visit that came in at, say, 8 o'clock, and then one at just after 9, and one before 10, and one just after 10. So obviously it's pretty straightforward to the table there, but you can see there's a different device ID, so a few different people going to a location. That same location then is going to need to have a scaling ratio. So we're going to work out for any particular day or hour or month, whatever the granularity is, how much do we need to inflate the number of visits that we received to get the true number of people that had worked through a particular space. And so in this case, we might say that number was a factor of 1.2. And so what I'm saying here is that for every one of the visits on the left, I need to multiply that number by 1.2 to get the true number of people that walked through a location. And when this scaling was implemented, it was clear that it posed a slight challenge in the fact that you can't do a direct join between those two tables, because the time that there would only be one scaling ratio for, say, the day, but visits come in at multiple times throughout the day. So if you try to do a simple inner join on that table, or in I've tried to give it sort of a Ruby style or a Rails style text on the left, it's not going to match anything, not directly. So what I did is the first thing I thought, well, let's find the longest running queries. What's taking the longest, and just sort of triage it. And the longest query I found, I intentionally chose a massive data set, tried to really make this big, and it came in at 195 seconds. It's kind of an arbitrary figure because it's just for this large data set, it was that time. But of that, 166 seconds was spent on just one method in there called hashed ordered batches, at which point I've just kind of gone, what? What's a hashed ordered batch? And that's an extraordinarily long time to spend on just one method. So we pull out that method. I come across this, and look, it's a bit overwhelming, but ultimately you can break down the longest running part of this query right here. It's this metric attribute symbolized keys. And if you can be excused if you looked at this and thought, what? Because it is a bit crazy, but there is actually some logic behind this. And what it is it's related to the ACTIVERECORD typecasting. So ACTIVERECORD tries to be really nice to us. So you pull this record out of the data. It says, I want you to get me just some metrics. And in there, I've got a field called visits, and it says, for that day, you had one visitor. So then we might say, okay, that's great. I would like to apply a scaling of 1.3 to that. And so you then multiply it together. 1.3 by 1 gives you 1. And that's because ACTIVERECORD knows that the visits column in that table is an integer. And therefore it returns the integer value, or in other words, it's just cutting off the 0.3. Now, most of the time, that's exactly what you want. But in this particular case, it's not very helpful. So the metrics attributes was basically converting that into a standard regular hash. And a hash doesn't have these same values. So if you suddenly then decide to multiply it by 1.3, you get a result of 1.3 back. The problem is that that process is extremely intensive, and it was just taking a huge amount of time. If we go back to this query, the other interesting part is the each slice. For those who aren't familiar with it, it's basically just running this query over smaller batches of data rather than doing it across the whole data set. And this is because holding that data basically would hold this data in memory. So if you were to pull the whole data set, and we're talking about large data sets, you would have the original data set, plus at one point you would end up with the whole data set duplicated as hashes. So that's a significant amount of memory. That each slice would mean that at any time you're only holding a portion that's come out of the database plus that final hash. But again, that means that you're making lots of requests to the database and it's quite slow. So the next step from here, sort of thinking, okay, well, let's take a look at where this is being implemented. And the next thing I found was that there's actually three queries that we're going through here in the same request. So one page load request actually hit this 3 times. And so the first query, you can see it's getting visits for a particular time range, where what we call is persistence false. And for us, a persistent device is going to be something like an employee's phone, or it's going to be the iPad that's used in a store. It's something that we see constantly and we don't want to count as a visit, because we're not particularly interested in knowing how often your employees move in and out of your store. We just want to know how many customers are moving around. The next query, you can see, has done almost exactly the same thing, but it's grouped by device ID. The third query starts the same, but this time we're looking for the persistent devices. We want to know how many unique persistent devices we had in a period. So essentially the process now when looking at this is you want to find the common elements. What are the things that we're doing repeatedly that we can actually we can group together and just do once? So clearly the first step is this visits for location time range. All 3 queries are doing exactly the same thing, but we're running that, hitting that database 3 times to get it. So to group these, I'm lucky enough to be working on Postgres. I imagine a lot of you are. Postgres allows you to do what's called a with statement. And a with statement is essentially a nice way to do subqueries. It's probably an easy way to think of it. You can keep everything nice and tidy. If you're not using Postgres, there will be a way that you can do this similarly in the database you're working with. And so the first with statement is going to be basically just getting those locations. We're basically taking that visits for location in a time range. It's a pretty straightforward SQL query there. But if you remember this guy that we were speaking about earlier, we still have that problem that we can't easily match in the metrics. Now, this is actually not that big of a problem to deal with, and it can be dealt with like this. And the magic here is quite specifically this date truncate. So all we're doing is we're saying, take these numbers that we had and just pull them all back to the day so that they're all exactly the same. And now suddenly your table on the left can actually match the table on the right, and you can actually do a join on it. So there's a huge saving in doing that, rather than pulling the 2 tables into your Ruby application and then trying to work with it. So going back to generating this common data, we're going to find what else is common. and we could see that there were 2 queries that are getting where persistent is false, 1 query where we needed to get persistent is true. So again, we've got a duplicate. Twice we're hitting to find the is persistent is false. So we can just make another with query out of this. And essentially we're saying, take that first one, which I've called raw visits, and just find me everything in there that where is persistent is false. And so suddenly we've managed to get the data we need for 2 queries, but just do it once. An important thing to note if you're going to do this is that you don't get indexes on your second with query or any subsequent one. Only the first query that you hit, or the first time you hit the data, is it going to be able to use the index. Now, in this particular use case, it's okay, because is persistent is a Boolean, and you are unlikely to be in a scenario where you can actually get benefit from indexing your Booleans. So in this case, it's essentially doing the same work. To move on from there, to finish off that first query, what it was doing was saying, give me the total number of visitors that were at this particular location. So we're basically just adding another with that just sums it up. We're just saying, give me the sum of everything that was in that previous table. So it's pretty straightforward there. Next, the second query was looking for unique visitors. And look, it's a good idea not to get too deep into the SQL on this because it's quite specific to the application. But I think what's important is that you can see we've reused this table non-persistent visits. So that was the previous one that we'd actually used in the last query, but we're just reusing that same data set. And from there, we finish off by summing up the unique visitors. I think that's the only thing that's really important to gather there. Apart from also, you can see in the second section where we've count by, we're actually doing this scaling here, multiplying by the scaling factor. So that was the work that was being done at the Ruby level, but now can get done just straight in the database because we've combined all these queries together. Finally, we were looking at, had to look at the unique persistent devices. And this was the section where obviously the persistent Boolean was different. So we're still reusing the data set, but reusing the first data set rather than the second one. So again, we're just reusing the same data. We haven't gone back to do another lookup. And we're just counting the devices that are in there. Putting all that together, we take those 3 summary with statements. So we had the summed visits in the first example, we had the summed unique visits in the second example, and then in the last example, the unique persistent devices. And all we need to do is just cross-join those. So basically the problem before is you've got three separate data sets that, but we want to return one result. So in this case, a cross-join actually works because each of those 3 is just returning one result. So the cross-join will return one result with the 3 sets of data. To now benchmarking this, we obviously started at 195 seconds, thereabouts. The new load time for this ended up being 13.8 seconds. Now, that time actually, I did that benchmark before I ended up doing another refactor today that takes another couple of seconds off that. So I put the refactor into the previous code, but didn't have time to update the benchmark. But you can clearly see that it's quite an astounding difference that makes it worthwhile. I think the important takeaways here is SQL is actually, it's less reusable. It's harder to, in the sense that it's harder to pass that SQL around your application. This was really reusable in the sense that I've taken multiple queries and combined them into one. But I can only use it in that one query. If I've got other parts of the application that need data, it's difficult to have them share that same query. And most of your problems can be solved using ACTIVERECORD. And in fact, today I was spending a lot of time doing some more SQL work and went through a few iterations to ensure that I could find a way to use ACTIVERECORD rather than using SQL, because it's going to be easier to pass around those methods we're creating rather than having to write SQL every time we do it. On the other hand, if you find examples like that one, the benefit that you get from writing the SQL is extraordinary. And what is really important is understanding those situations, just knowing when those situations are. And most of the time, it's going to be things like this where you see you're doing the same thing multiple times, or similar things. They may not be exactly the same, but they're so similar and there's slight differences. And at that point, you need to say, okay, stop, maybe I need to look at SQL. And I think it's okay if you're not proficient in SQL. If you can find these, it's actually pretty easy to find examples of SQL code. It's been around a really long time. A lot of people use it. It's actually really, really easy to Google. And so even if you're not comfortable, just recognizing it and giving it a go is actually going to give you great results. Now, I do want you to take time to give me some ridicule. I think I also have some time for questions if there are any. Up the back. Sorry, I can't hear. I have used database views, yes. Sorry, the question was, have I ever used database views? I certainly have. I don't use them in this particular application. For those who don't know, essentially a database view is allowing you to essentially create a query that then acts like a table on your database. So you could query the table on the database that is actually really just looking at, it's actually just running a query in itself. There are certainly a few ways you can achieve that. In this particular case, I haven't found a lot of value for it. I've certainly seen some great use of not just views, but also in Postgres materialized view. And a materialized view is essentially, it's almost like a cached version of your query, and so you can get really fast results. Because of the real-time nature of our application, that's not particularly valuable. Also, when using when there's only a single application that's dealing with a particular type of code, I quite like having the code in my Rails application, so there's always one place to look for it. That's something that probably people later come up to me and debate, but I'm happy to have that debate. That sounds like a great talk that you should put into the GitHub. So. I haven't found any support for with. Sorry, the question was, does ACTIVERECORD have any support for with? Because most of the code that was shown can be done with ACTIVERECORD, but the with statements, however, are a problem. If someone finds a gem that does with statements, I will love you. I will buy you beer because I would love to have all of this in ACTIVERECORD for the reason mentioned before, the ability to pass around the scopes that you've created. But I haven't seen it, no. And to be clear, like the vast majority, exactly as you said, the vast majority of this SQL was me rewriting what ACTIVERECORD was doing, but putting into with statements with some. We still have a question to the right here. No?
I was going to ask, but I think I actually already know the answer. I'll ask it.
You're welcome to ask still.
Wasn't clear to me, but was your application previously doing that join on the date table in Ruby? Because it wasn't lining the dates up properly?
Sorry, so the question was our application doing the join on the date table in Ruby? And the answer is yes, it was, and it was horrible, and it took a really long time. And that was exactly why I had been fighting for so long to be able to do that optimization. So I think one of the biggest benefits came from doing that join in the database. That and the hash, turning everything to a hash is extraordinarily slow. Despite the fact, to the best of my knowledge, I believe ACTIVERECORD is still using hashes under the hood. But that, for some reason, that was the killer, was actually making that transition. Yeah? So the question was, is the scaling factor reliable? The answer is it proves to be very reliable. I have absolutely oversimplified how it works. And there's a fair bit of, the detail of how we come about it is too great to discuss right now, but you could ask me off stage. But yes, it is actually quite reliable. But happy to have that chat when I'm not standing here. Any final questions? Yeah, at the back.
Sorry. Do you reckon the speed's similar if you were using a different database, like PostGRESQL or NoSQL or Mongo or something like that?
Yeah, so the question is would we get the same benefit in another database? I would say absolutely yes. What we were doing in Ruby is just not what you're supposed to do in Ruby. That's what databases are designed for. In NoSQL, I guess there would be dependencies in there. It would depend on how you're going to join the tables up. It would depend on the NoSQL database you're using. But I would say regardless, trying to take an active record data and then slam it into a hash is probably not a great thing to do. And anything that you can do in the database when it comes to things like grouping and joining and that sort of stuff, just do it in the database. That's what they're designed for. Great. Okay, thanks guys. If you have any further questions, you're welcome to hit me up.